Hi everyone, my name is Albert and welcome to our series on vectors. In this series, we'll be going through the topic of vectors as it pertains to the HSC Maths Syllabus. We will first introduce the definition and properties of vectors and then show its various applications to geometry, motion, and forces in 3 little episodes. So firstly, let's look at the 2 types of quantities, scalar and vector. A scalar quantity is a quantity that is only defined by a magnitude, so it can be expressed as a number. For example, quantities like volume, mass, and time are scalar quantities since they are completely described by its magnitude. However, a vector quantity is a quantity that is defined by both a magnitude and a direction. Quantities like force and velocity require not only a magnitude but also the direction involved. This is why we represent vectors with arrows, since we know how long the arrow is and in which direction the arrowhead is pointing. So in the real world, we often want to describe an object's motion. For instance, distance is a scalar quantity that just contains a magnitude. The distance between A and B is 200 meters. Whereas displacement is a vector quantity that also shows the direction as well. So the displacement of AB is 200 meters northeast. Likewise, speed is a scalar quantity whilst velocity is the equivalent vector quantity. Finally, acceleration is a vector quantity with no special word to describe the scalar version. So in this series, we'll be exploring 3 episodes. 1. Properties and operations. 2. Projections and applications. And 3. 3D vectors and further applications. In episode 1, we cover the basic properties of vectors and investigate how to use mathematical operations with vectors. First, we go through the various ways to denote and write vectors. Then, we understand the difference between equivalent and position vectors and learn some special types of vectors called the zero vector and the unit vector. But importantly, we also learn how to resolve vectors into horizontal and vertical components to have a standardized way to represent every single vector in the universe. Secondly, we also learn how to use operations with vectors, because what does it even mean to add, subtract, and multiply vectors which are just simply arrows? So we learn how to add and subtract vectors and also learn something new called a dot product. Finally, we tick off some axioms or fundamental laws in maths that we are allowed to use when dealing with vectors. In episode 2, we focus on vector projections and applications through various questions. Vector projection is when we project one vector onto another vector, like how a shadow is created on the ground by an object in the air. The length of the projection, or the shadow, is called a scalar projection, and the vector of the projection, including its direction, is called the vector projection. For the purposes of exams, most of the questions will utilize applications of vectors. We will walk through some geometrical applications of vectors, where we have to recall some of the properties of geometrical shapes and then apply them to vectors. Then we also have applications related to motions and forces, where we can represent a moving object or different types of forces using arrows. We actually have a bonus episode for you installed that follows King Sisyphus, rolling a boulder up a hill for eternity, where we have to use vectors to resolve forces and answer some questions. In the final episode, we explore vectors in 3 dimensions and run through some further applications. The third dimension, or basis vector, is Z. Fortunately, all the properties and formulas that we learned in 2D extends really nicely into 3 dimensions. So we revisit the notation, formulas, and how to use operations with 3D vectors. Finally, we explore further applications such as expressing equations of 1D lines and 2D planes using vectors. So that's a wrap for episode 0 on the big picture of vectors. I hope you enjoy the series and conquer the realm of vectors. So like, subscribe, and leave a comment below on what you would like to learn in the future. I'll be there.